Greetings, my name is Andre Cirizari, and this is part 2 of my preliminary review for the design of ultrasonic test equipment. And in this part, I will provide a very elementary theory on display systems which may be used on the ultrasonic test equipment for this project. There are 3 scan displays which can be used. These are the A scan, B scan, and C scan systems as seen below. More information can be found on the AMS Handbook for Non-Destructive Evaluation and Quality Control, and that is also where these images are from. On the A scan, which is typically viewable on an oscilloscope screen, you will have the plot of echo amplitude versus time. A typical screen you will see a large initial pulse from when the transducer begins to read the the response from the test piece. If a flaw is encountered, you'll typically receive a smaller echo if the echo is smaller than the sound beam. And then finally you will get a large back reflection from the back wall. Sometimes if you have a very large echo, you will not see this back reflection and you will see a larger flaw echo. The applications of this are typically to find flaw depth, flaw type, and test piece thicknesses. Also, flaw sizes are typically compared to standard test pieces with known flaws. On a B-scan display system, also readable on an oscilloscope, you will see the echo's response time versus position. So the transducer will travel over a test piece and take multiple readings in a planar fashion, such as this. So what you will see is you will get the response of the amount of time that it took the ultrasonic signal to pass, and if a flaw is encountered, you will have a smaller area between the initial initial wall here and the echo, so it's a clear method of visualizing in a planar view the location of a flaw. The application of this is to find a cross-sectional view of flaws, and also find flaw locations, shape, and the relative length in one direction of flaws. Lastly, there's the C-scan display. This will typically, in contrast to the A-scan and B-scan, will have a gate versus planar position. So an echo as compared to an A-scan display, you will have a gate, say, behind the initial pulse and before a back reflection, so that if a flaw echo is found, then you read that there has been a flaw, and then you plot that. So the locations of the flaw in a test piece will be easily read because the transducer will be traveling in a planar fashion throughout the test piece, and then if the echo is encountered, you will be able to see in what location these flaws are present. As far as applications, these are for locating flaws on a planar view, and approximate flaw depths can be found by varying the gating. So for instance, if you say that the gating is between this location and this location, it will not read a flaw. But if you do have it between this location and this location, then you will read a flaw. And this is an example of an actual screen output, which is also viewable in the AMS Handbook for Non-Destructive Evaluation and Quality Control.